Welcome to the solution video for the Soda Machine Unit Tests Challenge. Let's go over to Visual Studio. We have our project from last time where we have our library, we have our iDataAccess, we have our iSodaMachine logic. So what we're going to do first, before we do anything else, is we're going to create a class in here inside of logic, and we're going to call this our Soda Machine logic. Now I know this is a unit testing video, I made it public, but we're going to need to have an instance to a concrete type when testing. So you can't use .NET Standard. You have to use .NET Core or .NET Framework. So we're going to use .NET Core. Now I prefer XUnit, but you can use NUnit or just a unit test, which is an MS test project. Any of those will work. And I have had the question, well, why is XUnit better than NUnit or better than MS test? And really anymore, there's pretty close feature parity between all three. Now, XUnit and NUnit have kind of led the way, and MS Test has kind of followed along in their wake. And so XUnit and NUnit tend to have the newer features, the nicer features first. But even so, they're pretty well caught up to each other. XUnit and NUnit especially are pretty much the same thing, it's just different names. They have pretty close to the same approach. There's a few differences in how you approach things, but for the most part, it's up to you which one you prefer. And that's based upon a preference in how they do naming and maybe a preference in how they do certain. Then let's split this into a horizontal group. So now the logic is up above and we have our testing down below. So I'm going to start one method at a time. So I'll make this bottom one a little bigger. I'll get rid of this test one. So we need to add a reference, so a dependency, add reference to our Soda Machine library for our tests. So our tests have access to the Soda Machine library. We can add a using statement using Soda Machine library and using, actually we don't even need a Soda Machine library directly. We just need .data_access and using Soda Machine library .logic and .models. There we go. So there's all three using statements we'll need. And that's for our three namespaces. Now I added data access, even though there's no concrete type for this. There's no data access concrete type, because we're actually going to create the concrete type in the testing class, not in the library. So we'll create basically a mock. Now you can use a mocking framework like mock, M-O-Q, to do mocking, but in this case, we're actually going to create almost a full data access layer, but it's just going to be in memory. And that way it's really easy for us to use it for testing purposes. So let's create a folder in tests, and I'm going to call this mocks. And inside here, I'm going to add a class, and this class is going to be data access. And this is going to implement that interface. So control dot to add the using statement, and then control dot again to implement the interface. So this is now our interface, or our concrete type for data access. And it's a mock version, basically an in-memory version of data access. This is a really quick little application. It's going to allow us to do a few things. So for example, we're going to have this coin inventory. So I'm going to create a prop that's a public list of coin model, and that's going to be the coin inventory. Okay, so and we'll initialize that to be a new list. And now what we'll do is whenever you add coins, we're going to say coin inventory dot add. And we're going, actually is it add or is it add range? It's add range. And so we can add in our coins. That's all it's going to do. Okay. So get all is going to return coin inventory. All right. So you see what I'm doing here? I'm just doing just enough. I'm saying that this is our database, which of course is not a database, but it kind of is. It's an in-memory database. And the reality is we could actually use this probably in our actual data access to say, well, we're going to do an in-memory database. And maybe we do that. Maybe just take this and put it as an in-memory database. Maybe clean it up a little bit. But I'm going to make this public so that when you say add coins and you give me 3 coins, I'm going to look at this and see, does it have 3 more coins than it did? And are they the right 3 coins? Or does it have just 1 more coin? When you say get all, I'm going to compare that to this. Now, of course, it's going to be correct, hopefully. But that way, when we return all, we know exactly what we're going to get back. I'll also initialize this data access with some basic information. Maybe some sample coins, some sample machine info, and all the rest, so that when it comes time to work with this, I have a sample of a known set of information. I know it's going to have 5 Cokes and 3 Diet Cokes and 2 Sprites. I know that information. Therefore, I know how it should react, so I can test to make sure that my data access, my business logic works the way it's supposed to with the data access. Okay? So we're kind of doing the bonus challenge first, but this will really help us when it comes time to write our tests. So coin inventory, withdraw coins. Okay, so we have our coin inventory. So we're going to need to do a little bit of link here. So what we're going to do is we're going to return our coin inventory where, let's do our control dot add using system dot link, and say where x dot amount equals coin value dot take, and the quantity to take is quantity. All right, and then to list. And what this will do is it's going to give me all the values, all the coins that match that amount, and then it's going to take that many off the list. So if it returns back 5 quarters we ask for a quarter. It returns back 5 quarters. We're only going to take 2 of them if that's all we asked for. Now, I'm not going to return this quite yet. So var, let's call these coins equals. Now, what we're going to do is we're going to say we need to remove that. So coin inventory dot remove, and we're going to remove all that match. I believe this will work. So we'll say coins like so. And it's going to go, no, you can't convert that. So let's flip this around. Let's say coins dot for each, and then say coin inventory dot remove the item. So for each one, remove it from the inventory. Now it's not going to remove all the quarters the first time you remove a quarter, because it's removing each instance. And so each instance is unique. And so even if the values are the same, the instance is different. Therefore, we're saying remove each instance from the coin inventory. Now we can return coins. And that should give us what we need. If there's no coins, then it's not going to remove any, and it's going to return back a null list. If it's only 1 coin, but we need 2, so you say 2 here, but there's only 1 on the list, it's only going to return back 1. It'll remove that 1 from inventory, and it'll return that to you, but you only get 1, not 2. Which does mean, by the way, that if we get 1 back and they say, okay, we'll look for dimes and nickels to match up. We don't have enough of those. We're going to throw that error, but we're also going to have to put the coins back into inventory. So just keep a note of that. All right. So that's a little bit trickier, but that's the coin inventory. Machine info dot cash on hand equals 0. And it's yelling at us here. It's saying that it can't modify the return value of data access dot machine info because it's not a variable, which is interesting because I want to treat it like one. So what I'm going to do is say var val equals. Actually, I can just even do this. Nope. Var val equals machine info, and then I can say, I should be able to say val dot cash on hand. There you go. And then I can say machine info equals val, which I'm not quite sure why it's yelling at me about this, because I should be able to set this and it should just work. I should be able to say machine info dot cash on hand equals 0. That should work, but for some reason it doesn't. I'm going to have to talk to the developers and find out why. Either way, return, and this is going to be, this would be the original value, which I don't have. I should have captured that. Output, which I don't have. We're going to say decimal output equals val.cash on hand before we reset it. All right, so now we've captured the value, returned it, and we've also set the cash on hand to be 0. So there's empty cash. So now soda price. Well, this is going to return machine info dot soda price. Total income, return machine info dot total income. Takes care of those two. And now soda inventory. So this is something new. This is a list of soda models. So therefore, we're going to come up here and create that. A list of soda model, and this is soda inventory. And we'll create a new list for that. Okay, so now soda inventory, we're going to say soda inventory dot add range sodas. That's the add inventory. Get all. Return soda inventory. All right, notice I collapse these after I'm done with them. That way I know that I'm done with them. Get soda for a particular soda. So what this is going to do is just return that soda. Really what we could do is we could just return back the exact same one, but I don't think that's going to work well. Instead, what I'm going to do is return soda inventory dot where and say x dot name equals soda dot name and x dot slot occupied. You know what? We're not even going to make the user worry about that. So just the name. Match the name and say first or default. And that'll return the soda, or it'll return null if that soda is not in inventory. Get types. So this is going to be a grouping here where we get a unique value. And it should be a pretty easy one for our in-memory. So return soda inventory dot distinct. And so we'll return each distinct element. And what that should do is, to list. What that should do for us is get each one that has a distinct value in it. What I'm wondering though is that might look for distinct objects, instances, and since two instances may have the same values, but they may be distinct because they're a different instance, a different house that was built off the blueprint, that might not work for me. So what I'm going to do instead is I'm going to do a group by. First, I'm going to say, let's group by the name. And then after that, I will do a dot select and say from my my x equals x dot first. So group by, grab the first one in each entry, and then from that to list. So what that should do is it should take our, and let's see if we can tab this over a little better. There we go. So we have our soda inventory. We're going to group the elements by the name of equals 0 to clear it out. Oops, we have a problem. It's based upon the user ID. So we can't just have user credit like this. We need a dictionary of type string decimal. And we'll say equals new dictionary string decimal. That way, down here, what we can do is we can say clear out based upon that user ID. So we'll say user credit for our key, which is user ID. And we'll say that for user ID. And we're going to have to get the value from this. So we do need to check to see if there's a value because we have to add to it. So let's do this. Let's do user credit dot try get value and user ID, and we could say out decimal, and the value is going to be total or the current credit, like so. And then we can say user credit dot user ID equals. Wait a minute. I'm doing the insert, not the deposit. So I'll continue doing the insert. We'll move it down, and then we'll come back up and do the deposit. I'll look at that going, wait a minute, we have no value being passed in. So let's just cut this out of here, and let's paste it into here. This is where we're going to say current credit plus amount. And that's going to be the new value for this value. What happens if there is no out value? This becomes a 0, and we add that to the amount, and we create that key and put it in there. Okay, so that takes care of the insert value. Now let's talk about the deposit. Deposit is where we take the value, the money that the user had in place, and we put it into our into two places actually. We're going to put it into the machine info. Where is it? Machine info cash on hand and machine info total income. And yes, we're going to put the whole thing in total income, not just the value that we got, because that total income will tell us how much money is in the tank. And we'll just obviously subtract out later in our accounting software the fact that we put in coins for change. So we're going to add this to two places. So we're going to get machine info, actually var info equals machine info. So get that value, that tuple. And then we're going to say info dot cash on hand plus equals, and this is our user credit. So user credit, and this is for user ID. And that's assuming that value is there. But at this point, you have to make that assumption because if there's nothing there, then we're not depositing anything, and yet we're telling the user we are depositing something. So I think it's good to throw an exception at this point, but maybe we do a little bit more of a targeted exception. So maybe we do, instead of just allowing the exception to happen and having this weird exception, we could throw a user not found exception. Okay, so if user credit and what we found contains key. Okay, contains key user ID equals false. So if there's not a user ID that matches, throw new exception. And we can look through the exception list if you want. There might be one down here for user exception, but probably I think exception is probably good enough. And we're going to put a message in here though. And this message is going to be that user not found for deposit. I think that's probably pretty clear. We might come back to that and make it a little bit more clear later. So that's, now you've verified that this is a valid value. So we can come over here and also say info dot and total income plus equals user credit user ID. Like so. And with that, we've now added it to the two spots we need to. We've deposited the money. Now, we should probably, are we going to clear this value or not? I think we probably should. So in that case, the user credit dot, and we need to remove, and we remove the user ID totally from the system. So it's going to wipe out everything about the user now that we've deposited their money and we're done. Okay? So with that, let's collapse these down. We can come down to user credit total. And all this is going to do is very close to what we have here, where we grab this, we paste it down here, but instead of setting it equal to 0, we're going to return it. I'm not sure why my insert is on, but return equals like so. Not return equals, wow. Return that value, and we can say else return 0. So it returns a 0 if there is no person found. Otherwise, it returns the value. We could also do, probably maybe a cleaner way of doing it would be to do a lookup. So you've got here, not this one, insert, try get value. This might be a little cleaner. I think it is. So we do a try get on the value. It's going to return back a 0, or it's going to return back the money. And either way, we'll return it. Okay? So that's a lot of work to get set up, and that's a lot of setup stuff. And we're not quite done yet, but what this does for us is it allows us to have a full mock. Okay? Instead of mocking individual pieces, we can mock the entire class and use the different pieces in our testing. All right, so now we're going to create a constructor. And let's do it right after our properties. So CTOR, and in this constructor, what I'm going to do is we're going to insert some standard values, some known quantities. So we're going to say that coin inventory.add new coin model, and we're going to have a few values here. So quarter and the amount equals 0.25. All right, so there's one, and we'll add a, Gotta say 0.25 M for decimal type. Let's add 4 quarters, and then we'll add a couple of dimes. So this will be 0.1. Let's add 2 dimes, and we'll add a nickel. Let's add 5 nickels. So there's 5 nickels. So now we have all of our coins for our coin inventory. Now, machine info, let's set up some basic information for machine info. So machine info equals, and we have the soda price. Let's make our soda price 0.75 M. Cash on hand. This is how much money is currently in the machine. Let's start with 2565 M. And our total income is 201.50 M. All right. And what it does is it gives us some starter values. And now we can say, okay, if someone makes a purchase, we're going to add that amount to our total and to our value on hand, or our cash. To run out of something. Okay? So now we can new up an instance and know all this information. So let's go back over to our tests, and we can start creating our tests. Let's open back up the soda machine logic, and let's split this out again. And I will shrink this up to what we need. Let's start with just the add coin to inventory. Okay. So let's create a public void add to coin inventory, and let's just say should work. Okay, and we'll make this a fact. All right. And what we're going to do is we're going to just make sure that when you have coins and you add them to the inventory, that they show up in the inventory. All right. So let's start with a data access DA equals new soda machine library dot. Nope, that's not right. I call it data access, but we already have a data access in the soda machine library. That's our namespace. That's not a good thing. So let's call this this class mock data access. And yes, we want to rename that to be mock data access. We'll save it. And so now we'll call this mock data access control dot to add the using statement where it won't conflict, and say equals new mock data access. So now we have our mocking data access. We can say DA dot add coins, and we're going to pass in our coins, which we don't have yet. So let's create that. And this is the setup portion of the test. So we'll say that's going to, what is the type there? It's a list of coin model. So list, which control dot to add the using statement for that. Coin model. Coins equals new list of coin model. And we're going to add a few coins here, just a couple. So we're going to say new coin model, and this is going to be the name is quarter, and the amount is 0.25 M, like so. Oops, no semicolon, comma. Copy that, and we'll add 2 quarters, and we'll add a dime. How about that? So we're going to add that to the list. And now what we're going to have is we're going to need to do the actual versus expected. Now, this method in particular, it should be really straightforward because we're just adding to the list. There's not anything going on in this add coins inventory class or method. So we're really just testing to make sure it's not doing anything before it calls the coin inventory add coins. So what we're going to do is we're going to say the actual, and we're just going to do an int actual equals, and we'll say da dot coin inventory dot where control dot to add link x dot name equals quarter dot count. Whoops, this is expected. Sorry. I'm sorry. The actual. No, that's actual. Okay, and the int expected is here. And we'll just say I don't remember what it was. We're going to add 2 quarters. And our mock data access already has 4 quarters, so therefore it should be 6 quarters total. That's what we expect. And we're going to do a count of the quarters and make sure that it's going to be 6. So we're going to say assert dot equal expected actual. All right. So what we're doing there is we're going to add the coins to our data access, and we're going to make sure that, but that's not quite right because we're calling the data access directly, and that's not okay. We need to be calling the add to coin inventory. So let's do this. Let's get rid of this, and we're going to create instead the soda machine logic, call it logic, equals new soda machine logic. Now, we need to pass into that soda machine logic through a constructor. So let's create a constructor here. We need to pass in an iData access. Control dot to add our using statement and call it data access. Now we'll leave it alone. We won't actually do anything with it. But that's because we know we're going to do that for our dependency injection. And here we can pass in DA instead. And what this will allow us to do is it will allow us to pass in our mocked data access instead of the real data access, which means that when we come down here and say logic dot add to coin inventory and pass in our coins, it should be that it modifies our data access, calls data access, and adds to the inventory. We're going to check our data access because remember, we passed in instance, but we have that same instance. So we can now look into that instance and see what's happening as it's being modified by another class. So when it's modified and we add 2 quarters, in theory we should see that it changes the value to be 6 quarters. That's what we're checking. Let's save this. Let's go to test and say run all tests. It's going to build first. We can go to our test explorer and it says, no, it didn't work because you have a not implemented exception. That's a good thing. And here's why. We called this method. It didn't work. So it threw an exception. So down here when we have an expectation, the expectation is not met. Therefore, we fail the test. when we make a change to this method so it does work, then it should be the test succeeds. Now, just to prove that, we're not going to do this for all of them. I'm not going to undo it. I'm done. But I'm going to actually implement this by saying, let's come up here and control dot to add initialize our field. And then down here, I can say data access dot coin inventory dot add coins. And that's all we have to do to make this work in theory. So if I were to go here and say run all tests again and let this run, it should be now we have a green passing test. That's what we're going to do in the next lesson. But for now, let's undo this. I'm going to undo all of this, including the private variable here, the private field. Because we're not going to actually, let's actually do one more. There we go. Got our not implemented exception back. So that way, we have our failing test, but we know our test is valid because it is failing, because it's getting that exception. And now I can make it pass. So there's our first unit test. Now let's move on to the next class. We're not going to do tons of unit tests per method. We're just going to do basically one per unless we find that we need to have more. So let's say fact, and we're going to say public void add to soda inventory should work. Okay, and that's the expectation of what should happen when we add to the inventory. So we're going to kind of model what we've done here. We'll actually do both of these steps right here. We could put this into in fact, let's do this. No, I'm not going to worry about it. I could do a setup here, but we have to return back both of these variables anyway. So let's just call this good as it is. So I have these two variables, and now I can do something with them. So I'm going to have a list of soda model, and I'm going to say sodas equals new list of soda model, new soda model, and the name is going to be, let's go with Coke. I like Coke. And slot occupied equals 1. I know that from before. Oops. There we go. It's a string. I'm going to add 2 Cokes to the list. That's it. So we're going to add to the inventory. And so what we're going to do is we're going to have our actual and expected. So int expected equals how many Cokes do we have originally in the list? We have 1, 2, 3, 4, 5 Cokes already. So therefore, we're going to have 7. That's what we expect. Int actual equals DA dot, and we have the soda inventory dot where name, x dot name equals Coke count. And then we're going to do our assert dot equal expected and actual. Now I haven't actually inserted this yet. So let's come down here. And here's the deal. If you didn't actually do the insert, what would happen? Well, if we run all tests now, it's going to build and it's going to run tests. And this one says not implement exception. Cool. This one's failing too, but it says expected 7, actual 5. That's not what we should be getting. And the reason why is because we're just doing a check on our data access, and our data access hasn't changed, but that's not the point. empty money from machine should work. I'm creating should works because these are all kind of a happy path. I can come back through and add more tests that say, okay, this one maybe should throw an exception if you try and remove something that's not there, or, I don't know what else. But that should be what should happen. We're going to test the edge cases, but we're testing the kind of the main actions, the main ways of doing things right now. So we'll paste in our setup, and then we'll have our logic dot empty money from machine. And what that's going to do is going to empty all the money from the machine. It's going to return back a value. So let's do our decimal actual equals, and that's going to capture back how much money we emptied from the machine. And before this, we're going to say decimal expected equals DA dot machine info underscore cash on hand, like so. And that says cannot convert to a non-delegate type decimal. Oh, it's a method. So because I'm returning a tuple, it actually creates for me a method. Nope. I want machine info. Okay, but I don't want all the machine info. I want, that's a tuple, notice, but I just want one value out of it. So here's what I'm going to do. This machine info returns back, let's do a var, and it returns back a soda price, a cash on hand, and total income. I don't care about the first and the last. So underscore expected underscore, like so. Now, what are these underscores? These are throwaway values. Basically, what it's saying is this is a write-only variable that you create where you can put information in that you don't care about. So it's a discard character is what it's called. And so we're discarding these values. I only want back that middle value, which is the expected value, which is our cash on hand. All right. And now I can do an assert dot equal expected and actual. And that should validate that what we've had in the machine beforehand is what came out. Now we can do one more assertion. So we can say expected equals 0 and actual equals DA. Actually, we can do this. Equals DA dot machine info. All right. And now we can do another assertion on that same comparison. What's this doing? Well, we're saying the expected is now 0 because that's what should be in the cash on hand once you empty the money from the machine. So we're actually testing two different things. And so now you've emptied the machine, we should see that there's a 0 in the actual value. Okay, so that's the next test. That's the empty money from machine. Okay, now I can move on. Let's not collapse that. Let's move down. Get coin inventory. So let's copy these first two lines. And tests can have repetition, and that's okay. This is get coin inventory. Should work. And there's our setup work. So we have our setup. What we're going to do is we're going to get back a inventory of coins. So let's just say that our var expected equals DA dot, and this is going to be our coin inventory. Okay. I'm going to say coin inventory. See, if I just say just da.coin inventory, The problem there is it's an instance of the list. It's not the actual values. Now I could do toList, and that's going to create a copy of the list, but then the two lists would not compare. So instead what I want to do is I want to grab values out of it and maybe do some counts. So coin inventory, where x.name equals quarter count. And now I can assert equal expected and actual. So what's it doing? Well, we're getting right from our data access class directly, we're getting the number of quarters that they have in stock. And then we're comparing that to what the coins that come back, how many quarters we have, and make sure they're equal. So that's the comparison there. We could do the same thing with dimes and nickels if you wanted to, but I think that one is enough for our purposes. Now let's make this a fact. So make sure it runs as a unit test. And now we've been a couple times now since we've done this, so let's run our tests and make sure that in fact all of them fail and all of them get a not implemented exception, which is good. Okay, we can copy this and move on to our next method. Get current income. All right, so this is a lot like this one right here. I'm actually going to copy this, this right here, but I'm going to make sure that I don't call the empty money from machine. I'm going to come down here, I'm going to say fact, and then public void. We're going to say get current income underscore should work. And I'll paste that in, but instead of this, I'm going to say it's get current income. It should return for us the actual value, which is what we're getting expected. So that should also work the same way. So that's actually a really easy one to do. Yes, it is copy and paste, and that's okay. We did have a change here, but again, tests can be copies and pastes. Okay, we're not trying to keep tests dry. We're trying to make sure we test all the different possibilities here. So that's our current income. Also note that while we want to have good test coverage and want to make sure that our tests test all the different edge cases and those kind of things, if we miss something, it's okay. It's not the end of the world. If we find out we have a bug in our software, which tests are hopefully going to help us find beforehand, but if we have missed a possibility, we find a bug in the wild, then what we do is we create a test to replicate that, and then we fix it. Not the test, the code. And then make sure the test turns green. All right, so that's what we'll be doing if we need to. So now we're going to create another fact, and this is going to be public void get money inserted total. Should work. All right, so this is the amount of money that's been inserted total. This is for the user. So this is the amount of money the user has put into the coin machine. Now the interesting thing is, and let's shrink this down a little bit. That get money inserted total, I'm pretty sure that has to do with how much the user has put into the machine. So money inserted and get money inserted total. It is, but that's per user, which means we have to have a string user ID. We missed that. So let's go over to our interface and money inserted and then get money inserted total. We need to have the user ID, which also means up here, money inserted, we need to make that pass in a user ID as well. So we actually found two problems or flaws in our code. So we're going to have a issue here, right down here, money inserted. We're going to have to take in a user ID as well in order to now implement that interface properly. So that takes care of the that issue. So now we have our money inserted, and now we can actually do a call for it. So let's do this. Let's grab our setup, and then we're going to grab our actual. And our actual is a decimal, and it's going to be decimal actual equals logic dot, and this is get money inserted total, and for a given user ID, okay? Which means that we have to actually insert money in for a given user. So let's insert for user test, okay? And what we're going to do is beforehand, we're going to say, this is the setup portion, DA dot, this is going to be the user credit, okay? User credit dot add, and we're going to add a key, which is test, all lowercase, and a value. This is the total amount that's been added into this user, 0.65. And that's going to be a type decimal. Okay, so now the actual is going to hopefully return back to us 6. Back when we call this. All right, so that's now covering this method. Okay, let's tackle the get soda inventory. So we're going to say fact, we're going to say public void get soda inventory should work. And then in here, we'll take our same setup right here. And this is going to be very much like the other inventory, get the coin inventory, same kind of thing. So what we're going to do is we're going that we've inserted. So int expected equals 8. And therefore we're going to do a check. So assert dot equal, first is our expected and then is our actual. So now you may be wondering about, well, how do you know that's been set up? Because we may have run more tests, but we're instantiating this every single time. So we're starting off fresh every single time. So we have a known value inside of our class. Therefore, we know how our method should affect it, if at all, and then what the output should be. So this is how tests work. You have a known input or a known state, and then you operate your method then say equals logic dot get soda price, which that's going to return back for us. Oops, not get soda price. We're going to say da dot machine info dot, and there's soda price here. We can actually just ask for it, I guess. Let's just do that. Let's just ask for it. And we're going to say decimal expected. There we go. That'll work. So we don't need the discards. And now we can say decimal actual equals logic.get soda price. And that should return the same value. And we're going to assert equal expected and actual. All right. So we're just making sure that the value it returns for the soda price is the value that is in our data from our supposed database. Okay. And that just makes sure it's calling the right thing to get that soda price. That we didn't actually or accidentally get the wrong value from the tuple. Okay, so get soda price, again, that works. Get total income. Pretty much the same as this. So let's just copy and paste. I'll copy the name and we'll paste the name right here. So get total income is going to be the total income. And this is going to be get total income. So it's the same thing, just getting us a different part of that tuple, but it's the same basic concept. All right, issue full refund. Let's just, oops. Let's paste in just this. So we're gonna start with fact, and then we're gonna say public. Let's scroll up a little bit. Public void issue full refund should work. Like so. We'll paste in our setup code. And now what we're going to do is aha. It's going to be logic.issue full refund, what we're going to call. And we're going to pass in our user ID. But what that's going to do, we're going to have to look for da dot, let's scroll through the list. I think it's user info. So user credit, and we're going to look for user credit on test, and that's going to be our expected value. That's our starting value. Okay, let's take a step back here. Because we're starting to get into the actual doing it before we put any values in. Remember, we have to add dot user credit, and we're going to say user credit for, and let's use a string variable here. Let's call it user. So let's just say string user equals test, like that. Don't have to keep retyping test. So we're going to say the user credit equals 0.65 decimal. Okay? And now what we're going to do is we're going to say that the decimal expected equals, we don't have to get expected yet. So what we're going to do is we're actually going to use a different type of test here. So once we issue the refund, let's just do the actual steps. So now that the refund has been issued, it should be that for this user, there is no money left. So therefore, assert true, and we're going to say this person's value equals 0. Okay? It's not a assert with an expected and actual. This is just asserting this is true. And what should be true is that the user that's specified has a 0 value. So it's a little bit different than the average test. It takes some getting used to think through how we best test this, how we set it up. But I think that'll work just fine. All right, list types of soda. So let's grab this again. And we're going to say fact public void list types of soda should work. And we'll paste in the setup code. And now what we'll do is we're going to list out the types of soda. So what this is going to do is it's going to go to our data access and get a list of all the soda we have in stock. It's going to have all of this. So we can do probably, let's just do one check. Let's just do a count. So 3, 4, 5, 6, 7, 8. 8 items is all we're going to do. Now, I remember checking for 8 above. Soda inventory should work. Types of soda. That's what it was. So this, we have different types. We have Coke, Diet Coke, and Sprite. So we have 3 different types. So it's a little bit different. But what we're going to do is we're going to come down here and say int expected equals 3 for 3 different types. Int actual equals logic dot, and this is list types of soda dot count. And that should give us back 3. Therefore, we can assert equal expected and actual. Okay, let's move on to the next. Let's create a string user equals test. Now this will be a GUID normally, this user ID, but test is also a string, and that's fine. So what we're going to do is we're going to say let's not do any kind of insert, but we're going to say logic dot money inserted. User is the user, and then the monetary amount. Let's create a decimal for this. Money equals 0.25 M. Okay? And then we'll insert the money. Now, what we're going to do next is we're going to say decimal expected equals money, which is 25 cents. Decimal actual equals DA dot user credit for this user should be that same 25 cents because it's starting off with 0. So therefore, adding 25 cents, it should be assert equal expected and actual. Okay, but we're not going to stop there. We're going to do another assertion. So now what we're going to do is we're going to insert the same value. So logic dot money inserted for the same user, the same value. Now the user should have 50 cents. So expected plus equal money, as in we're adding money to it. So we're adding another 25 cents, that'll give us 50, and actual equals DA dot user credit for that user. So this is what we expect to have happen. We expect to have 50 cents. We're going to check this user's credit to see if they have 50 cents. And we're going to do the same assert equal for those two values. Yes, you can have more than one assertion in the same unit test. So we're still just testing one unit of work, but that's what we're going to do for inserting money into a user. Now, we could create another test that, let's do that. Let's actually copy this entire thing. We're going to create a second test. And it's the same money insert user 2 should have correct amount. All right. So user 1, let's control dot to rename user to user 1 everywhere. And we're going to add the same process for user 1 where we add twice. Oops, that's the wrong one. I want to add twice. I'm going to do just the insertion, and then I'm going to, well, you know what? Like that. Okay? So I've inserted twice into this user 1. Now let's create a string user 2 equals Tim. And we're going to have decimal user 2 money equals 0.10 M for 10 cents. All right. And now what we're going to do is we're going to, in the middle of this, just to make sure it's kind of, I want to make sure that we're inserting the right values in the right people. So I'm going to mix them up and do one then the other than the first one again. And now what we're going to do is we're going to do our assertions on the expected versus actual. So we're going to do the same thing as up here. So we're going to say decimal expected equals user 2 money. Decimal actual equals DA dot user credit for user 2. And make sure that is in fact 10 cents. Assert equal expected actual. So I'm testing a different scenario here. I'm testing to make sure that if I have two different users using this machine, and user 1 puts money in, and user 2 puts money in, and then user 1 puts more money in, I want to make sure that user 2 only has access to user 2's money. So that's what I'm going to check here, is to make sure user 2 only has the money that we expect them to have. Now I could check user 1 as well, but I'm going to leave it just like that. All right, so there's the money insert. I've actually done 2 unit tests for that one. Now the last one on the list happens to be the big one, and this is the request soda. So let's grab first our setup, and we're going to say fact public void request soda underscore should work. And you might change this from should work to something else. In fact, we should probably change this money insert single user should have correct amount. And yes, these names can get long, and that's okay. Now I'm going to leave this. Request soda to be just should work for now. We're going to figure out what we want to test to see if it's valid or not. So let's think through the different ways this can work. Let's think of a happy path first, which the happy path is when things just work. They just happen to work. Everything clicks. There's no problems. So soda would get returned. So if you ask for a Coke, you'd get a Coke back. You'd have no change because you gave exact change. And you have no error message. So let's do that. So let's just say instead of should work, should return soda with no change. Okay. So what we're going to do first is a little bit of setup. So we're going to say da.userCredit. We're going to have to create a user. So string user equals test. And so we're going to say the user equals, I believe it was 65 cents. Let me check to make sure. Oh, 75 cents. So 75 cents is the amount of money that the user, or that each can costs. So let's leave that open. But 75 cents. So we're going to put 75 cents into my user's credit. All right. And this again is setup. This assumes we've already gone through and put money in, and we've gotten to that point. This is what we're testing, is if they did, then how does this method work? Okay. Now what we need to do is we need to ask for a soda. So let's do a soda model. Soda equals, how about expected soda? Equals new soda model, and the name is going to be Coke. Now, I don't care which aisle it comes from. So, but I'm gonna tell it slot occupied equals 1. Because if I ask for a Coke from slot 1 and I get a Coke from slot 2, that's kind of weird. So since I'm going to ask for the list of sodas that are available and I'm going to request a soda, I'm going to know which slot it's going to be in. So therefore, I'm going to ask for it from a certain slot. So therefore, I'm going to know this information. So that's the expected soda. So now what we're going to do is we're going to capture all 3 of these pieces of data. So I'm going to say var results equals, I'm just going to say results, one name, okay, one type. And then I'm going to say equals logic.request soda, and I pass in my expected soda that I'm supposed to get. Okay, that's going to give me back results, which is now a tuple that has soda, change, and error message. So I've got the values back now from my soda. The other thing I should do though is I should capture a couple more pieces because if I ever do decide to start changing those initial states, I could modify my test to be okay, but I really don't want to. But let's just do it. So var initial state equals da dot machine info. And that's going to give us back a tuple. And that tuple will have soda price, it will have cash on hand, and it will have initial state. Initial state? No. Total income. There we go. Initial state's a variable name. So total income. So now what we can do is we can do some checks based upon this information. Now I could create variables called actual and expected for each of these, but I'm going to do quite a few asserts. So instead I'm just going to do it right in line. Assert dot equal, this is the expected. So this is going to be our expected soda dot name, and the results dot soda dot name. So make sure those two are the same. Also assert that expected soda dot slot occupied is the same as results dot soda dot slot occupied. So make sure the soda is correct and that actually has a soda. It actually 0.75 decimal is the expected, and the DA dot user credit, nope, not user credit, machine info dot cash on hand are equal. So the initial cash on hand plus 75 cents, which is what we had in credit, that's now should be the cash on hand. This same thing should be true. Let's just copy and paste it. But instead of cash on hand, it's going to be the total income should be equal to the total income later plus 75 cents. So we should increment both of those. Make sure both of those are incrementing. Also, we can say, let's just do an assert, too many S's there, assert dot true on the results dot error message dot length equals 0. Okay? Make sure that it does not have an error message. It's an empty string coming back. Okay? Actually, you know what? Let's not do a length check. Let's just do a string.is null or white space. And make sure that that's an empty string for error message, meaning there's no error message coming back. And let's also do a assert. Let's do assert equal and say 0 and say results dot change dot count. Make sure that the those two are equal. It says, do not use assert.equal to check for collection size. How about assert.true instead? Okay, it likes that. So we're going to do assert.true for the count being 0. All right. So we're going to make sure that we don't have any change coming back, that our error message is empty, and that it's correct soda, and that it's changed our values for our user credit to be 0, and that it's changed the cash on hand and total income in the positive by how much we just inserted. That's a lot of testing all at once. Okay. But that one action has a ripple effect, and we're testing those ripples. So now what we're going to do is we're actually going to copy this entire unit test, and we're going to paste it. And what we're going to do is this should return how about should say, instead of return, should say not enough money. So we're going to do the same exact request, except we're going to have 50 cents in our user credit. And we're going to request a soda, and we're going to, instead of saying that the soda name and all that matches, what we're going to say is let's do a true. And we're going to say that results dot soda is null. Okay? So make sure that it is null. And actually, now that I think of it, I believe there's if you go here, I believe there's actually a method. Let's look. There's not null. So there's probably a null. Yep, there is. So there we go. We're doing a null check on soda, making sure that it's not returning a soda. And the user credit should be the same, 0.5 decimal. It should not have changed the user credit. The cash on hand should be the same. And yes, we're going to check this, because what if it took that and put it into the cash on hand accidentally? Okay, so we're going to check these two. And the error message should have, should say equals, actually, is there a false? If not, we'll do, yes, there is, false. Which is just flipping a bit is all it is. But assert this is false. That is null or white space, error message is empty. So it's not true. All right. And the change count coming back, that should still be no change coming back. Okay. Now let's take this method and we will copy it all over again. Whoops. Let's copy it, not paste over top of it. And we'll paste it in. And we're going to now say that instead of saying not enough money, we're going to say out of stock. So we're going to say out of stock. And we're going to ask for a Fanta in slot 4. Okay? Which we don't have a Fanta in slot 4. Therefore, it's going to have a null return back for soda. We're going to start with let's change our credit to be back to enough money. But we're still going to make sure that we still have that same credit in place. And the cash on hand, total income don't change. There is an error message, and the change being returned back is nothing. Okay, so now we're checking to see if we're out of stock. Now let's go back to the first one we did for these. So this one right here, I'm going to copy this again. This is the working one, the one that should work. And we'll come down here at the end, we'll paste it in. And this time what we're going to do should return soda with change. All right. And so it's going to return more. We're going to have $1 here. Let's do that. So $1. So we're requesting a soda, a Coke, which is 75 cents. We're expecting back the name and slot to paste it in, and we're going to tweak some data. So same exact test, but here's the tweak to it. So this should return with alternate change. So the idea is we don't have quarters in stock. Well, how do we make sure we don't have quarters? Well, what we're going to do is we're going to remove quarters. And that is da.coin inventory remove remove all where it matches x dot name, actually x dot amount equals 0.25 m. So it's going to remove all of the coins from the inventory that are quarters. So they're all gone now, which means that the coin inventory, if we look, it's going to have 2 dimes and some nickels. That's it. So therefore, when we do this, it shouldn't just get us 1 coin back because that would be a quarter. We don't have a quarter. We should get back 3 coins because we're going to get back a dime plus a dime plus a nickel. So that's 10 cents, 10 cents, 5 cents. That's 25 cents. All right. So that's what we're going to get back is 3 coins because there are no quarters in the system. All right. And that, I think, is a pretty good start to our unit testing. Let's make sure that all of our tests run. So let's kind of shrink this down here. We got a lot of tests here. The correct logic. And if it is, it will turn the test green. And it will say, yes, that is correct. That's a passing test. And once we get all green tests, we know that our logic is in place and all correct. Now, we may have bugs still. If we do, we write a test. We make it not work. We make it act the same way as the way it is now in failing. And we get a failing test, and then we make the logic changes to make it pass. We get a green test, we're good to go. So this is how the idea of test-driven development works. Now, usually you do one method at a time. You don't do a whole test class, but we have all of our interface methods, so we have the ability to do this. And now we can take it in chunks instead of having to do a piece here, a piece there. Okay? So thanks for sticking with it. I know it's a little bit longer than the normal weekly challenge, but hopefully you've kind of got the idea and the concept behind this, and this is really starting to click, and you're ready to go to these tests. If not, I think the next lesson where we start actually putting the logic in, you start seeing those tests turn green, will really be an eye-opener, where you'll say, oh, okay, I understand now, and it'll kind of give you some of that confidence to work with your application, create unit tests, okay? Now, we do have this mock data access. Now, we're going to create a real data access. We probably won't create unit tests for it. And the reason why is because it really is going to be as close to the metal as possible. What I mean by that is it's just going to ask SQL for data, or just going to ask text file for data, or just going to ask MongoDB for data, or just insert. So we're not going to test that portion. I'm not going to go into SQL unit tests or Mongo unit tests and all the rest. But I think this gives us a really good handle on the logic testing of our application. Okay? Thanks for watching. And as always, I am Tim Corey.